In this class we will do image classification using maximum likelihood algorithm. So first step is to load the previous data which we created in lab 15, mask_nawabshah.tiff. So once you have added that data, the second step is to generate cluster and signature file. You will go in spatial analysis tools, multivariate ISO clusters. So go in spatial analysis tools, multivariate ISO clusters. So here you have to give input, which is basically mask_nawabshah.tiff, and output signature file as sig.gsg. So we will give an output at sig signature.gsg, and the number of classes will be 10. Press OK, it will execute and will create a signature file. You can find this file in the result folder. You have to refresh it and there will be a file known as sig.gsg. So the third step is to classify image with maximum likelihood classification. So maximum likelihood classification function you can find in spatial analysis tools, multivariate, and there you find maximum likelihood classification. Give an input, which is the TIFF file, give an input signature file, which is your sig.gsg, which we created in our second step. Then give it an output name. So I'm giving it nclassify.tiff. So you save it, then press OK. Keep other parameters default. Once it is completed, you will get 10 classes. And now what you have to do is identify the features on the land and assign respective color to the land use. So because there are different classes, now what I'm doing is I'm assigning green color to those areas which are in agriculture or vegetation, blue color to the water. So again, this is a green color which is to agriculture land, and then I will assign 7, which is a barren land. So this all you have to take it from your experience and also from the first visual interpretation of your composite which you created earlier. So assigning or identifying respective land use. The next step would be to reclassify it. Now what we will do is we will reclassify the classified image into 4 classes. So 1 will be agricultural land, 2 will be build up, 3 will be barren land, and 4 would be water. Now hit the reclassify tool, select and classify image as an input. Reclassified field will be a value. Then you have to identify which color you gave to the 10 classified 10 classes image, and you will assign the new value to it. So in our case 1 is agriculture, so all the classes where we have given green color we will assign 1 values, and where we have blue color we will assign 4, which is water. So what we are doing is giving it standardized numbers so we can identify which class it is into 4 reclass values. We do same for all other classes. So once we are done with the assignment, we will give it a name. So I'm giving it unclassified2 to the new classified image. So once we have completed it, now we have 4 classes image. So now we know 1 is agriculture land, 2 is built up, 3 is barren, 4 is water. So we will assign respective colors. You can directly do it by double clicking it, or you can go into the properties and go into the symbology and assign respective color and name. So 1 is agriculture, so we will give green and write it agriculture land slash vegetation. Now we know 2 is build up areas, so we will assign gray color to 2 and assign build up. For 3 we have barren, so assign yellow color to the barren. Now 4 is our water, assign blue color to it and give it a name water. So now we have identified 4 land use classes, agriculture, built up, barren and water, using unsupervised classification. So there is another procedure which we can do without creating signature file. We can directly use ISO cluster unsupervised classification function. So you can go into spatial analysis tools, multivariate, and then go into ISO cluster unsupervised classification. Select your the main raster file, which is mass_nawab. I'm using 6 classes, as I know 4 classes I have to divide it. So then I will give it an output name and give it a color and repeat all the steps which I did in earlier procedure, is to identify the features and then reclassify it. So in coming steps I will identify the features and I will reclassify it. We'll do reclass and reclassification. Again the same step. We'll select the new classified image and give it the respective number. So now you can see that I got the same file with 4 classes, and now I can assign it the color as I did in previous procedure. Green for agriculture, gray for build up, then barren, and then blue for water. So these are 2 procedures where you can use like maximum likelihood algorithm to do unsupervised classification. And now our next step would be to calculate area under each class. So I will use the image which I used for the first procedure, so you can use any of them as you like. So here now what I'm doing is giving it the labels to the new classified which I did from procedure 2. So what I will do is, for calculating the area, I will use N-classify2 image which I did in procedure 1. You can use any of it. So in this step, for calculating the area, what you have to do is convert the classified raster into a polygon. So you will use conversion tools from raster to polygon. So input will be N-classify2.tiff. I will use field as value. Field will be is equal to the value, and output will be class. Or you can give class, classes, or class area, whatever name you want to give. So now let's do the conversion from raster to polygon. So select N-classify2.tiff field value and give it a name like class or classes.shape. Now you can see attribute table. In attribute table you will see grid code, and grid codes will be 1, 2, 3, 4. So each area what we identified is converted into identifiable grid code. So if suppose I want to select agriculture only, so I can select grid code is equal to 1, press OK, only agriculture land will be selected. Now as I want to calculate the area under the each class, the first thing what I want to do is add a field name as area, as we did in previous exercises. So I will add name field area. I'll select double as a type, and then what I will do, suppose I want to get the agriculture area, so I can select by attribute. So I can use grid code is equal to 1 because I know 1 is agriculture area. So then I can calculate from using calculate geometry. I can calculate the area and use hectares as a unit. So now I can use summary statistics to calculate the sum of the area of all the polygons coming into the agriculture land use. So you can do same for other grid codes, like for built up area, for barren, and for water, how much area is under each class. So I will write here, suppose agriculture, and the area which I have calculated in hectares, I will copy from there and paste it. You can round it off to, like, because hectare is a big unit, so you can do it like 5.3, or you can use integer class when you are assigning an area field, so it will always be rounded off. So do the same for other classes, calculate the area and complete this table. Thank you very much.